along with us is the Professor V.C. Rao, who is an eminent researcher and professor and adjunct faculty of our department for the past 2 3 years. And he is having a very good expertise in the parallelization of the architecture, supercomputing, and use of this cloud computing environment. He was the main person among those the team who has built the Param supercomputer and the latest one, which is also being used as a part of the cluster of the deep learning in India. So I welcome Professor V.C. Rao for this faculty development program keynote as a keynote speaker. And I hope his talk will be very much useful to you. Pertaining to this faculty development program, as in order to make not a tedious and a tightly program, we have made this flexibility that maximum user can use this and can attend this. So 2 sessions we have made, one in the forenoon and another is in the afternoon. So 9 to 11:30, 9:30 to 11:30, and another is a 4 to 6 p.m. And in that, all those majority of this hands-on experience and the interactive session pertaining to this cloud analysis part that shall be there. So I hope that the participant would be very much happy and enthusiastic to attend this program. And with this, they will be able to know about the basics of the cloud systems and the more analytical part, the research currently which is going on. So in that case, the many research work that we have undergone pertaining to the security and the establishment of the cloud and making that useful with that multiple different type of that scenario where that managing of the cloud computing is a challenging one. Pertaining to that, the simulations and the hands-on experience using that existing cloud network scenarios or the environment that shall be shown to you where all those type of the simulation works, their outcome and the use of the virtual environment and the practical environment, practical scenario with that available of the with that available cloud system, the user will be able to understand that. So having said that, I would emphasize and state that all the participants that you would be very much uh, happy and will get all those type of that expertise which you may claim that having that knowledge you would be more empowered to get the placement, better placement in the academia or industry. Pertaining to that, the participant from the academia side, the hands-on that slides and the resources that shall be provided to all participants. So using that, you would be able to make this as a part of the curriculum if it has been there. Mostly it is in as an department elective part. So you would be able to get aware and use those slides and the resources to make the lectures and exercises to the student so that they would be able to understand and you would be able to teach them in a better and efficient way. So with this, I welcome all the participants and the faculty members who are the keynote speaker of this program and other faculty members who are the key resource person of this program. So I welcome all the participants and the Professor V.C. Rao, adjunct faculty member of our department, and the senior scientist of the CDAC, Pune. Uh, so uh, he is also the member of the National Supercomputing Mission, and he has made the important role in the development of the parallel processing platform, as I say, the Param. Earlier, when I was a student, the Param 10,000 was that the very first supercomputer that was installed in my institute. So I was unable to use that, but having that with the institute was a big news for us, and the huge advertisement of that was there. So he was the senior director and having a vast experience of his expertise in the high performance computing. He is a regular visitor of our department and other various institute of repute, and he has done very uh, interdisciplinary part of that work with the other foreign universities and the research institute. So I welcome Professor Rao and give the stage to you, sir. Please.
Thank you very much, respected head of the department, Dr. Mustaq, and distinguished faculty members and students, researchers who are participating in the cloud computing analysis and security. And then I sincerely thank MNIT Jaipur Computer Science Department and their director for conducting this one of the important FDP program where focus is more on solving large problem and security aspects of the data as well as the systems. So what I would like to convey today is I will discuss a little bit more about the cloud computing deployment and services as well as the security. Maybe I will spend some 30-40 minutes, then take some 2-3 minutes break. Again, I will continue like this. You are always welcome to discuss with me at any time, and I will provide the all presentations and other things also, maybe in a day or two. Thank you. Let me start. So, I'm audible now?
Yes, sir.
Is visible also slides?
Slides are not visible.
1 second.
So, sir, please do share again the slides.
Now, okay?
Yeah, now it is visible.
So we should also get, being a first lecture, we can discuss complete ecosystem over the cloud computing infrastructure, services and deployment, and we'll slowly walk through the challenges, issues in the security also.
Yeah, sir, you may continue in that way, whatever that you feel comfortable. Please go ahead.
1 second. So if you really see in this course, we may require to get some idea of the important topics, mainly focusing on deployment model and services,
Yes, sir.
and
Okay.
also security and compliance, and many other things also we should get exposure actually. And we need to make foundation in the 2-3 areas, which is a prerequisite for the many of the cloud computing users as well as the administrators. Let us go through some of these things. I pick up maybe 1 or 2, and I will discuss today. Let us see. So if you really see the complete spectrum of the cloud computing architecture, which has been developed from last 10 to 15 years, evolution and importance is one of the things which we should know.
So,
And
sir,
also
please
the-
go to the previous slide.
Yes.
So I would just like to emphasize that this is the topics that you have mentioned over here that are more useful and pertaining to that the various hands-on exercise and the research which has been done by our team that would be discussed. So that will be very much useful. So I think that majority of that part which we would be covering in this has been highlighted over here. So this is a good initiative from your side, sir. Thank you.
Welcome, welcome. So in our FDP course, we have nearly 8 to 10 days with 40 hours. Once we get a foundation in many of these topics, then we can focus on one or two topics as the domain expertise or the expertise in the various areas actually. So we will cover means if you really see what I have discussed in the last slide, what we need to know is one of the thing is evolution and importance. That means how the cloud computing has been started and how it is doing since last 15 years, how the security has come into the picture in the last 4 years actually. The second one is cloud service models. Earlier we have the 3 service model: infrastructure as a service, platform as a service, software as a service. Now we have the function as a service, and we also have the content as a service. We also have authentication authorization also service. Many new service also has come in the last 3 years, which we will discuss also. That means if you really go through the cloud service from last 3 years, the infrastructure service, we have more GPUs added, and we have the more shared memory systems added. And then platform is also totally changing. And the software means we recently brought the PyTorch and PyTorch GPU also as a software service. And function as a service will explain all the things. Deployment models, earlier we have public, private, hybrid cloud, but now hybrid cloud is one area where the security is basically focused, because you have your data is moving from multiple sites, and every multiple sites you may have the private or the public. When you have public cloud, then you look for the security aspects, authentication, authorization, compliance, and everything. The another new area has come in last 3 years is multi-cloud strategies. That is also another area where the 2-3 clouds can work together, and what kind of services which we provide. That is also another thing which we need to focus actually. So in these 3 are cloud service models, deployment models are completely important for every researcher and every student also. Now, when come to the architecture side, you have the layers of cloud architecture, that is the physical, virtual, virtualization, hypervisor, middleware, platform, application service. Middleware and application, there are a lot of changes happened in last 4 years, where the security is also coming into the picture. And compute side, we have the virtualization, we have the containers, we have the Docker containers, and we have serverless functions where many events can process. That is also now brought in the cloud computing in the last 3-4 years. Storage and the storage, now the storage APIs and the block storage and file systems, all things also brought into the application actually. And networking, you have the software defined network, load balancers, APIs. And you have the cloud native architecture. That's what how we can integrate containers, virtualization, and Dockers, and Kubernetes, and orchestration. All things are required in the cloud architecture. So cloud architecture is totally a combination of different layers which we need to understand also. So these are the things which we need to go through and then try to understand all these things. So now how do you read the programming? Programming is, we have programming paradigms for the cloud, event-driven programming, or the reactive programming, asynchronous processing. In earlier, if you see the cloud programming, we have the big data Hadoop MapReduce, and we have later the moved from Hadoop to the Spark, and then scientific applications, message passing. And now last 3 years, GPU and high performance computing, big data is integrated actually. So many events keep coming, means in the cloud, you have the large scale SMP shared memory systems, and that's how they drive the performance actually. So basically look for end-to-end solution in the programming paradigms for the cloud. And also people are thinking about how many man hours we invest to for the making the program up running end to end, and what is the ecosystem. All these things also important. Now the last 4 years, besides software development kit, there is the APIs also grown actually. So you can use the API which internally calls, which internally integrates the many heterogeneous devices, and then try to run your application much faster actually. The last 3 years, the serverless programming is growing actually. That means what many events you wanted to parallelly simulate, and every event, what kind of resources required, what kind of storage required, all things also very, very important actually. So now the another one is that from the beginning, scalability is one issue, fault tolerance is another issue. Both, how do we really address? This is also now they have bought the distributed consciousness, the blockchain also they brought into the many of these things also actually. So now in the programming in the cloud, if you see, these are the 4 important topics. We need to understand at least first one is very, very important. And then second and third one is growing. And the last one is mostly important for the distributed consciousness actually. So this is what we need to get idea. Now beside these things, we also have to understand the security and compliance, identity and access management. That is also another service which has come in actually, and data protection and encryption. How the security has been really addressed in all these things also we need to get some idea. And now emerging trends means how the cloud computing and edge computing, fog computing are really integrated, and how the machine learning workloads on the cloud runs, because you require big systems with the GPUs for the training, and training you do 64-bit, 32-bit, but for inference you do 32-bit, 16-bit, 8-bit. So that is also very, very important. Quantum computing in the cloud also, people are now using many of the IBM Qiskit and other systems which are available. The other thing is a cloud native development with DevOps. DevOps means the security programming as security part. 5 years ago, security is separate. Now, security part you can really embed into your code also. When you embed into the code, you can do code development, code testing, and security development, security testing. All things are come under the APIs. Because of the APIs, the DevOps also growing in the last 4 to 5 years actually. So many other things is that normally when we solve the high throughput applications or the high performance applications, what is the performance trade-off? What are the scalability trade-off? How much is the latency? That means how fast we can process the task on the cloud systems, whether it's iPerformance or the HPC, or how much is the performance. All these things also equally important. So it's a gamut of 10 to 12 major topics. In each topic, you have the many subtopics which we need to understand also. So that means if you want to focus on what I have discussed in the last 4 or 5 slides, what's really happening in the cloud, we need to understand also. One is that cloud computing is a structured compute, storage, network, and application services. These are the 4 actually: compute, storage, network, and application services. So we can focus more on compute or the storage or the networking or application services. That means here, the security point of view, APIs are there. Storage point of view, APIs are there. The compute, we know different kind of compute, that is whether you have the cloud consists of the Intel based system or AMD based system or the NVIDIA based system or the IBM based system. And networking is also whether you have the level 1, level 2 switches. Storage, you have the direct attached storage, or using SQL storage, non-NoSQL APIs, database storage. All things are very, very important actually. So let us go through some of the things. So in brief, I skip some of the definition for the cloud computing, which many of you know, but I can simply mention that a model for enabling ubiquitous ubiquitous, convenient, and on-demand network access to shared pool of configurable computing resources, and that can apply rapidly, provision and release with minimal management effort. So how do we get the end-to-end solution for this such kind of cloud computing infrastructure, storage, network, and solution? That is another important thing actually. So now if you really see, if you go back to the 4 to 5 years ago, then you have these are the delivery models, deployment models, defining attributes and resources and infrastructure. And then that's how has been now in the present FDP program, how these things have been now developed in the last 4 years also we'll discuss actually. And we also get some idea about the security aspects also. So now what are the important takeaway for the organization or for the students or for the faculty members? One is that choose deployment model, whether you choose public, private, hybrid or multi-cloud. When you go to all these things depends upon the regulatory process, security aspects and cost requirement. So regulatory, security, cost requirement is another major concern for every user when they choose the cloud computing infrastructure. Presently, most of the cloud computing infrastructure is used for the AI applications where they have the big systems with many GPUs, which we'll discuss also. So this is the first point. Second point is that basically we bring in new services. One is database as a service, identity as a service, anything as a service. That means what user wants, what cloud service provider gives, the granularity of the control that can be now defined in the form of services. Earlier, first 4 were there, infrastructure and platform software. Now the last 4 has been included in the latestly last 4-5 years. And in this identity as a service, anything as a service, where many of the security aspects have been included also. That will be covering maybe in second half or maybe next my lecture on 11th of September. We'll see. So this is second one actually. The first, if you really see the first one and second one are tightly coupled actually. So we need to be very careful about what kind of application, what kind of characteristics which we have, and what kind of resources which we expect actually. So let us go to the next one. So now let us see from other side. Other side is that, okay, I have my applications. I only look for performance and scalability because I need some resources on demand. I need some storage and computing power. That means my application may be high performance. That means I may use 1,000 nodes, 10,000 systems, or 1,000 systems, or maybe in the case of many of the AI tools like Perplexity or the ChatGPT or OpenAI, they have large cluster. Each cluster consists of maybe large cluster. Cluster consists of maybe 1,000, 10,000 nodes, and each node may have the many GPU accelerators. So these are things actually they provided now. So that means high throughput means how many number of queries or how many number of jobs I can process in a given amount of time, and what kind of system I require. Maybe I require a 1,000 core shared memory system, or I require a big shared memory system with many GPUs, or maybe I require a powerful head node in a cluster. All things we need to categorize and define. Okay. The next one is that resilience actually. When we really run the job or when we really process the complete application from user and the service provider point of view, revenue loss should be minimum, and continuity of the business with the customer should continue. That means many interruptions, many disruptions in the power, and many things about the storage and about all these things are basically we need to address. This is a major problem in the present era of the cloud computing, because application size is increased and private cloud is increased and public cloud is increased and multi-clouds are there. And with all the things, what are the failures happens when you really run your job, and how much it impacts your service delivery. All these things are also important. That's why it's the cloud fault tolerance and data backups and self-healing process. All these things, they write many scripts to see whether the job is really processing or whether the job demands are met or not. So resilience and the cloud resilience is the another area which is growing last 3 years only, because when the cloud size increases, the user wants application to run in the shortest possible time. And also the service provider will give the some kind of load balancing, and we also see the what are the features required for the application, and what are the failure happens, what are the fault tolerance happens. All things has to be clear cut, well defined. In other words, if you really see Hadoop MapReduce Spark program, it is a fault tolerance where the number of systems, nothing but number of racks in the actual Hadoop cluster, a number of racks, each rack is having the many GPUs, and you have the resource management and job scheduling, something similar to YARN, and how the fault tolerance can be addressed. All these things also very, very important actually. So that means earlier 2 slides, I talked about what we need to do from infrastructure and services. Now I'm talking from application perspective, what are the things which we need to understand, what service provider has to provide. These things also very, very important. That means you need a new architecture for the resilience as well as the scalability. Scalability means on the fly, you can deploy more compute nodes, or on the fly, you can do many things like virtualization, container, and Docker, and orchestration of the all framework, and provide some scalability as well as the resilience actually. So these are all the very, very important, which is very, very seen in the last 2 to 3 years. It is still in the development area. A new paradigms also required for the cloud, which is basically, if you really see the deep learning, machine learning, the training, which we take 64-bit, 32-bit, and inference we take 16-bit, 8-bit. Then you require new programming APIs for the distributed training as well as the inference. And also we require the Hadoop cluster integrated with the GPUs. All these things are very, very important from the new paradigms actually. That's why new paradigms, stateless function execution, many events can be processed on the fly. Elasticity aware means you can able to increase the size or decrease the size. That's what the scalability point of view. When you increase the size of the Hadoop cluster for the cloud systems, then you require many resources and many programming APIs and many workflows. All things you need to integrate on the fly actually. So how do we handle this one? So new paradigms are really challenging from the performance point of view, scalability point of view, as well as resilience point of view. Also, I discussed about the adoption of the DevOps and CI, continuous development, continuous testing, continuous investment. All these pipelines, the continuity of development, testing, and implementing security programming APIs and testing, everything is tightly coupled with the program automation actually. So that means what? Intelligently, the programs intelligently should choose various testing as well as these security deployment APIs into the source code, and then make it more reliable code actually. Earlier days, we used to develop the software and someone has to test it, someone has to do security testing. Now all are coming under a single umbrella. Because of single umbrella, the deployment requires more automation, and deployment requires more scripting programs, which we need to execute also. So these are the last slide. And this slide, what we talk about, little bit about the application perspective, so that you will understand how they can be really mapped actually. So other one is that we can also talk about the emerging trends and security, which I will skip some of these slides actually. So now the question is, if you really go back 3 years, 4 years ago, what are the things which we need in the cloud computing enabling technology? One is fast platform deployment. Today, it is no longer, it is completely changed today, because many of the cloud computing platforms require more number of devices, especially GPUs. And also today, instead of having more virtual cluster virtualization, we have the containers and we have the Dockers, everything is also moving. And we, instead of software as a service, we have the many other services also included in the picture. And we have the, earlier we have distributed storage, now we have the storage over the clouds with APIs. So there is a lot of changes happened in the technology from 2014 to 2020, 2020, 25 actually. So we need to understand some of these, what are written in this in table, the first column, all the things we need to understand from programming point of view, from application point of view, and what demands we really require also. So this is also another one which we need to see. So now if you really see normal cloud architecture, since last 15 years, we have the high-performance computing system, and we have the high throughput computing systems, and we have the many servers with more GPUs in the present era of cloud actually, and we have the virtualization resources, and we have the workflows and management. Now earlier we have the VM more, now we have the containers and Dockers, and how to orchestrate all the things. And we have the cloud computing management services, and we have the enterprise cloud, the private cloud, public cloud, and all these things are now as a general architecture which you can talk. Here now the security point of view, we need to understand security aspects at different places, which we will discuss maybe after some time, then we get idea actually. So what we really get to know is generally cloud means high performance computing systems, high throughput computing system with programming APIs and with workloads, with workflow management and firmware, and all things have been integrated. That's how the general systems have been now changing with respect to the application to application, especially in the case of artificial intelligence, machine learning, where you have the large language models, where you have the small language models, where you have the open software like LL Llama that has to run on the entire cloud in a distributed computing fashion. How do you really address those issues? So these are the things. That's why you can set up your own cloud, but it has its own limitations on many things actually. So this is how one of the CDAC Param, this was the sometime in the 2012, 2013, how this all these systems, if they are on a single cloud, then you will see how the Hadoop works, how the message passing library works, as well as the how the GPUs and every system works. All things are also really mind-boggling work for the system software middleware actually. Now, the another new area which is coming is application side, where the high throughput application or high performance computing required, where you have the 5G, 6G telecom traffic, where the messages go from origin to destination. What is the origin to destination? How many links it travels? What is the cost involved in moving packet? And what is the capacity? What is the demand? All these things are basically you have the many telecom network actually. These telecom networks every 5 minutes generates GB of data we need to process actually. So it's mainly a highly data intensive job, and these things you can really run on the cloud if you want to process the only data and do some analytics actually. Because managing big systems to process such kind of large telecom data is also very difficult actually. What you really see is that a typical telecom network in big cities, where you have the edge routers, core routers, and data coming from the outside, data going from inside to outside. How do you really address all these things? And every 5 minutes, if you take a snapshot, it will be GB of data going from one origin to many destinations, or many cities to many cities actually. So for this also you require the complete cloud only. I'll skip this portion, some portion actually. So what we require from application perspective is some applications require more memory. So what you see in this picture is the edges represent 0 to 1 scale, and then vertices represent the demand actually. Okay, so many applications in scientific and non-scientific applications. Some are basically performance, some are more memory intensive, some talk for more memory bandwidth, some look for I/O performance, some look for the shortest messages time taken, some look for the large network bandwidth. So application to application, requirements of all the seven will change. When they change, what kind of resources you need in the cloud, and how do we really provide is one question from the cloud provider, and programming paradigm and solving each from user perspective is another question, and how to get the end-to-end solution is another question actually. So with all these things, besides all the things, we need to worry about the cloud security also, the security aspect, what we really handle this one. Here, when we talk about network bandwidth, network latency, the data moves from one site to many sites in the cloud actually. When it moves to many sites, what kind of security protocols we use, what kind of security compliance we followed, and how we configure the entire cloud, these all things also very, very important. So what is important from application perspective is how to partition large data. Is it user responsibility or the software can do? In case of big data, Hadoop can do many things. Hadoop Spark and Hadoop MapReduce can do many things. In case of scientific applications, you need to partition the data and you put the appropriate APIs and move the data to every node. And synchronized mapping, how many you require in the cloud. So cloud service provider will think about how many kind of processes required and what kind of system required. And synchronization means whether the program runs on a single rack or multiple racks, then how do you address the synchronization? What is the communication that when the application requires broadcast or gather kind of communication or all-to-all communication in the case of Hadoop MapReduce, how do you schedule? So these all five influence the cloud service provider as well as the application developer who write the code also. So now what we do, the first portion we discuss about a little bit about the cloud computing and overview, and then from the infrastructure side, from the services side little bit, and platforms a little bit, as well as the application side little bit. Now we'll go into the one of the things more closely and try to see actually. So any questions so far what I discussed? So we will look into the evaluation part and then try to see. So what we covered in last 30 to 40 minutes is about the at higher level about the overview of the cloud and overview of the applications and architecture a little bit. Now we'll go a little bit details about the each one and try to cover actually. So first we'll focus. Any questions we have? Any questions?
Yes, sir. From my side, kindly elaborate FAAS services.
Pardon, sir. Repeat, sir.
You mentioned that along with this infrastructure platform and software as a service, another is that FAAS. So kindly elaborate that part.
That I will elaborate when I talk about the services completely. Services. I'm talking no services now. I'm
Okay,
talking about the services. I will elaborate with all the details now actually.
okay, sir.
So I gave the high level view. Now I'm going to the more details about these things. Then we get some idea actually. I'll come back to
Okay, okay. Yes,
the function
please.
services, function as a services that I will discuss actually.
Okay, okay. Please carry on.
Okay. I'm audible now.
Yes, sir, you are audible.
One sec. Let's go here. Slide move not. Slide visible now.
Yes, sir, your slides are visible.
Yeah, how to move? Some minor problem. Okay. System got some interruption for few minutes. You're going to see all the slides. Some interruption. I'm audible now. Visible.
Yes, sir, you are audible and visible.
So what earlier we talked about the infrastructure as a service, software as a service, platform as a service, and we also discussed about the various clouds which we know, public and private, which I did not discuss more details, but I'm skipping something so that we discuss what are the new services which are coming into the picture and how do you handle this one. So what we really observe is the PaaS and SaaS and IaaS actually. All the services are built on the same hardware. But earlier, now the hardware also becoming heterogeneous. Because hardware has become heterogeneous, we need to have the different kind of clouds for each one, or we have one cloud which can handle the heterogeneity. So that is where the importance coming now in the research from the software side actually. So most of the services are now handle the heterogeneity of the hardware, and then you can have the another approach is we can have multiple clouds, then we can integrate also actually. So in the new service which has come in the area is called FaaS, function as a service actually. Okay, that means what? Uh, when the developer wants to run a small piece of code, he can directly run it. That's called events. And you don't have to need the manage or the server themselves actually. Okay, that means specific business operations which are there in the application that can be really run using as an event, and that event is basically come under the FaaS as a service actually. So this is also file upload or the web request that also come as the FaaS. This has been implemented. It caters to the many applications in the finance domain actually. So that is one area. Second one is many applications in the medical and health also, the FaaS is actually used actually. So that means what? From the user perspective, it's only function, or if you don't work in a cloud, we call as a one API. One API is backend integrate with the different servers, different OS, and then run the code actually. That is backend infrastructure is much more complex to develop. And these all things has come under the function as a service. Because 5 years ago, many applications have the homogeneous system characteristics for applications. Now, today you have heterogeneity, many devices, many OS and the software stack, many devices means you have GPU, FPGA, and then you have the CPUs, and you have the CISC-based system, RISC-based system. So many things are there. How do you really run the job? That means you require a complete software stack that can address the heterogeneity that all come under the function. That means they call as a specific events actually. Okay. Earlier means we need to carefully see which server can be used, where are the GPU devices, everything. Now seamlessly you can integrate many heterogeneous systems with heterogeneous devices, then you can develop the software. Whereas from the cloud computing point of view, the FaaS is another service which is really useful. They have been implemented actually. Okay. So that is one thing which we need to understand about the FaaS. What are the key characteristics of the FaaS? One is serverless computing. That means it no longer you manage the servers, worry about the scaling. It automatically takes care of the event triggers. When the event triggers, it automatically get the resources and automatically get the programming APIs and run actually. So that's all event driven, more is event driven. And pay per use based on your application, what events you do, based on that you can able to understand the what is the workload you require and how much is the pay package also. Now the question is scalability means what? When the application runs, your workloads will change. You have more demand. When you have more demand, when workload changes, earlier is used to store the output data and resubmit and redo the work. Now you don't require to do everything. Dynamically resource allocation, dynamically resource changing, and dynamically workload changing. All things have been brought into the services actually. Simultaneously, the security point of view, which I will discuss, that is also has been taken now. Now, that means what? Earlier we talked about virtualization. Then we talked about the containers. Then we talk about the Docker's container. Now we are moving on to serverless architectures also. Okay. All these things have been provided by the Google and IBM, Microsoft also actually. More event-driven web applications, where the event-driven application means the burst data will come, burst data we need to process, especially medical informatics, where the 5G, 6G, many sophisticated medical operations, when they do, they can do the live to the many universities in the country. That is also require burst data actually. And then transferring, analyzing data, especially 5G telecom data, you would like to handle the telecom traffic data, and now you want to analyze the traffic data and predict what is going to happen in the future. That is also data processing actually. In the back end, you see when you talk about the telecom data, you talk about the audio, video, images, and IoT devices, edge computing, fog computing, and mobile application with cloudlets, all things will be integrated in this. And security checks and API testing also, DevOps can be done also. So FOSS is another one which is really useful, and many cloud providers provide. But the important issue is what kind of application do you really do, how the events will trigger, and what every event, memory requirements, compute requirements, workloads, all things are user responsibility. So these all things also, that means here, one way there is a lot of work for the cloud providers, another way there is a work for the application users actually. In between there is a middleware development is a major thing. So what are the questions which are really doing? That means how does the FAST different from traditional server hosting? What are the real world uses of the FAST? What kind of workloads it takes? And how it is compared with the platform as a service or the container as a service? And what are the limits? All the things are also research work which is people are doing now. They take many applications and demonstrate the how function as a services can be much better compared with FAST and CAS actually. Now, one more thing which I would like to discuss is I want to tell you, I am not discussing more about the platform as a service or infrastructure as a service or a software as a service, which have been there since last 10 years. Now we are adding something new, which we need to get exposure actually. Another one is container as a services actually. The container means at the software level, you get something from the kernel and execute. That takes less overhead compared to doing full virtualization actually. So that means a type of cloud service that allows developers and IT teams to manage, deploy, scale, and organize applications. That means when you run your application, we need to see what kind of virtualization required, whether you require container-based virtualization or the traditional virtualization, or do you require the Docker virtualization, or you require serverless. We need to see. That means there is a lot of work to be done by the developer. There is a lot of work to be done by the middleware software professional, and there's a lot of work to be done by the service provider actually. So what is the core concept in this actually? Means a user can manage this container as a service through web portals, APIs, command line tools. Okay. How it is deployed, and then how the containers are scaled across the clusters or multiple environments. So this is also come under the development efficiency and operational agility, which I am not going more details of the core concept of these services, container as a service. What are the key features? That means all the platforms automate container development, scaling, load balancing, and health management, and orchestration engines such as Kubernetes. All this portability is also another issue, making them portable on premises. That means your local systems, you can do portability also, and efficiency and scalability. So what is the important? Developer is abstractly infrastructure you need to know, and you need to build a software on that layers, and you can deploy. That means earlier you used to more worry about the hardware and virtualization layer. Now without worry about the hardware and virtualization layer, you look for the containers and then make an abstract way of defining the container with some resources, and then able to run this program actually. So this also the advantage of the container is that you can have the security, it can be improved, the container resources, container workload and performance, you can study. So all these things, if you really see, abstractly you can do all the development and then deployment on the containers on the local premises systems. So that will really enhance the performance actually. Earlier it was not, earlier container were not there. We used to use virtualization. Now there is a shift actually. Now, how do you place in the cloud ecosystem? That means what, where this place in the cloud ecosystem, container as a service, because you require the some kind of virtual machines, and you require some platforms, you require some infrastructure also. That means it's placed in between the both the things actually, mid-level between the clouds, and that means it sits between the infrastructure as a service as well as a platform as a service. So both things in between it runs actually. Okay. So container management is also very important. And what are the examples which we really see in the cache providers? One is Amazon Elastic Container. When I use Amazon Elastic Container, what does it mean is there is a scale down, a scale up will happen. And then that means when you do the scale up, you also have to worry about the workload. You have to worry about the infrastructure. You have to worry about the load balancing, many things also actually. So that means the cache deployment is already done in many of the cloud service providers. It is very useful actually. So what is the advantage? The advantage is how much automatization you can do from the cloud service point of view. Second one is how abstractly you can think complete cloud programming paradigm and cloud software service and write the application. That is also very important actually. So these things we need to understand, and we need to see. That means we need to understand VMs, we need to understand containers, we need to understand Docker containers, we need to understand serverless computing. All these four, what we can really choose at abstract level of implementing application is the most important actually. So the other thing is also the application, when you write like this, they are portable. When they are portable, you'll save more number of man hours to complete your project. From the operation side, it's very simplicity. It's a more automaticity. You implement the software services actually. Many other questions will be there also. So now the other question is, I also just skip some questions of this containers. I'll go to another one also. Let us see. Database also services. Now you see database services also, which is more and more popular. Why? Because you have the standard databases like MySQL, and then MongoDB. Now the Oracle purchased the NoSQL, which is a popular Berkeley DB, where they don't care about the hardware and they don't care about the software, but they mean that the user do not take care of hardware, software, everything. Database runs on the cloud. Now you can write the database NoSQL APIs in your program. When you write in your program is running, and then you are basically abstractly define the complete database in your program. Then what kind of resources, what kind of workload, how the load balance, everything can become more easy actually. So these also become another service. 10 years ago, your large database has been hosted on the cloud. You used to give the key and value pairs, an independent thing now. And used to write, as the time progressed, these people used to write scripts. But today you can write a program. In the program, you can put the NoSQL, what we call Berkeley DB APIs that can really seamlessly and concurrently work on large multi-core systems. That means the cloud storage and cloud infrastructure, when you put database as service, you can able to do the things much more easily. That means your programming will have one more subroutines with NoSQL, and some subroutines with the GPU, some subroutines with the PyTorch. All things can be integrated, and user have an option to write in an abstract fashion all those things. That's what the advantage in the database as a service actually. So what is the benefit? Reduced complexity, no need of manual installation, updates, backup. That's how the database availability and the system point of view. Resource-based workload using cloud controls. You can have you can write a program where based on the resources in the cloud in your program also, you can fine tune it to see the large database queries and large database processing you can do. So this is also very useful. So normally, how the database handles earlier, how the database services handles now, that is also very important. when you choose database as a query, what is the query response time and how its scalability, all these things also we need to understand. Security and compliance also we need to understand about the database services in the API actually. Another one new services have come in the last 4 to 5 years is this mashup of cloud services is there in the last 8 years, 9 years. But that means you can combine features, data, functionalities from multiple different cloud service providers. This is especially true in the telecom domain, 5G, 6G, health domain, where you have the many kind of audio, video images, plain text images, many are there in the application, and they are sitting at a different cloud centers. Then how do you really integrate actually? So that means what are the various clouds which are offering? All these things can be integrated and then provided as a service. This is called unified interface. In other words, what we talk about unified interface at the service level, we can also talk about the unified interface at the infrastructure level. That means you have the AMD processors, CISC architecture, you have the Intel processors, CISC architecture, IBM RISC, ARM RISC, and GPU devices, Intel GPU devices, AMD GPU devices, all seamlessly you can access through the unified interface in the hardware side. Similarly, what you see is that services also you can access through the combining all the things. That is also growing now. Growing means the user demands are like that. Because of the user demands, you need different services from different cloud providers. Can we integrate all the things? Earlier, you used to have independent codes running. Now you can integrate all the things actually. So generally, they use APIs, and these APIs and web services, and they fetch the data. That means what? The user, the advantage of the mashup of cloud services is user can think as access to aggregated services rather than information at one place actually. And instead of switching at different platforms, aggregated services are available means you can write more cloud applications in an abstract manner. So that is another advantage of having the mashup of cloud services actually. So this is also very useful. After the unified cloud services, I'll take some break of 2-3 minutes and we'll come back actually. So where we can use the cloud services, many things in the social media networks and financial domain, as well as the aggregating weather reports or aggregating telecom traffics in the last year, many months together. And then with all these things, the programming perspective, you write only 1 or 2 APIs to get the all data. But when you run the program on the cloud, it automatically gets the data from the different cloud providers and then integrate also. What are the issues? Issues are with the security, which we'll discuss also. So this is also another one where today you can see in our mobile also many services can be integrated and you can get the your output, predicted output also. That is also very, very interesting actually. Now, where the unified interface is used, because public clouds are in use, because the reason is that public clouds, it has more restrictions, no restrictions, and the policies are quite flexible, and security threats are reasonably more. That way, I think it's very easy. But now more and more they are moving on to private clouds because of the security compliance, as well as authorization authentication, as well as the other issues also. That way, now the mashup of cloud services is going to be part of the private clouds very soon. And why? Because there's a lot of sensitive data may be there. The data leak may happen when you do the public clouds. When you use the private clouds, it may not be possible so easily. So these are the, that means what? User wants to demand customized application and customized data and customized database integration. All these things are basically come under the mashup of cloud services, which are now going more toward the private clouds, which is very, very useful actually. So now that means what? When you come to mashup of cloud services, from pay and use point of view, you have the providers, vendors. cloud users, all three are there. When all of them are there, actually, you need to see what is the business software, the software the service provides, and what kind of developers prefer, vendors prefer, and how much is the compliance with the service level agreement. All these four are very important when you really look into the matchup of cloud services actually. I'll just, I will take some break of 2-3 minutes. We'll be back. Am I audible now?
Yes, sir.
We'll take break of 5 minutes. After that, we'll come back.
Okay, sir.
Not 5 minutes, 2 minutes.
Okay, as per your choice. Thank you. So meanwhile, I will continue to engage all these participants. So as my sir has wisely said that all these different type of that clustering and using that the cloud-based services in the distributed computing environment where that the resources are allocated in the different places, and pertaining to that, the challenges are there that how an efficient way we can use them pertaining to that the need and requirement. And especially in this case, the challenges are there that we have to focus on the availability and the usage of the resources. Now, here are those, as the professor has highlighted, that the part of that API program, which can be work or mounted as a function pertaining to a specific task that need to be performed. And in that case, the cost overhead pertaining to that need and requirement would be varying depending on that availability of the resources and pertaining to that task that can be computed. So likewise, that the professor has stated that we would be having a varieties of the platforms and the need pertaining to that task that need to be executed. Likewise, if I require to make a deep learning using the CNN or the RNN or the SNN, you may be aware about that, the spiking neural network or recurrent neural network and the deep neural network or the convolution neural network where the large data set is required. So the container who would be having those type of that space availability and the resource availability, we can take that and perform this type of the computation without changing the platform. So comparing to the unlike which has been used in that case, entire operating system, its protocol stack and all those software that need to be mounted prior to executing those type of tasks. Unlike that, in the container or services, everything is available. You just require to mount those functions over them and perform your task. So in that case, it is very much easy and usability of and flexibility that has been provided by those the data centers and the large organizations who are managing and providing such type of the services. So likewise, in our institute, we do also have our own cloud-based systems where the faculty and the research scholars who need the requirement pertaining to that, the resources are available for the period of the certain amount of the time, so where they can complete their work, research work, and submit their or return back that resources. So likewise, here is no cost is involved, whereas that the company seeks the minimal amount of the charges pertaining to that the type of the work and amount of that resources required. So in this type of the scenario, as you can see that this infrastructure platform and the software part that has been a fractionalized or that can be divided into multiple variants and you have the flexibility of using these type of the variants, and this is what that we would have to go through. Pertaining to that, the challenges are there that if the resources are not available and if we require to compromise our services, in that case, the challenges are there that how an efficient way we can make the alternate And pertaining to that, the focus has been given over here to give that type of that multiple number of the flexibility and the resource and the infrastructure and the platform availability where the user can seek any of them and that can be shared with that multiple vendors or the service providers. So now the Professor Rao has joined. So over to you, sir. You may continue. Over to you, sir.
Am I audible now?
Yes, sir. Please continue.
Now, another new service has introduced almost all 3 to 4 to 5 years. But see, the service introduction in the cloud computing from provider cloud servicer point of view, as well as the user point of view, and development point of view, all are tightly coupled actually. So now we talk more about the security side also, certain things which I will discuss in the next half an hour, but this I'll give you an overview. Identity and access management also now provided in the cloud. Basically, main aim is to authenticate users and authentication, authorization, control access to various applications remotely or campus. All these things are basically come under this IDaaS. So here, one sec. So what we really should know about the IDaaS is the identity management, such as single sign-up. This single sign was there in the earlier with computing, which I'll cover next time. Multi-factor authentication, user provisioning, and access control. That means what? The entire cloud identity management solution, which is required for the business needs, and secure and scalable and access control also. All these things are basically come into the picture as the users have been increased and infrastructure has been completely increased and diversified. So how do we understand this idea from the cloud service provider point of view is the most important. It's not moving screen. So what is the key aspects? The cloud-based IAM, they called identity access management. IDaaS handles authentication authorization via cloud infrastructure, removing the need for organizations to deploy and maintain complex identity systems. So that is also very, very important actually. Many users, password management, authentication, single sign-up, and many of the monitoring and reporting user access. This is one level of security framework which is there, which is very much essential. Then how do you handle multiple clouds, and how do you define the identity system, and how you really work with many other organizations in single sign-up. So all these things also very, very important. I'll go back to this presentation later. Let me quickly tell you what are the important we need to understand. What are the authentication mechanisms which we have to, how it follows, how it works, and After authentication, how the access management policies, and then how the single sign up with credentials. How do you automate the provisioning and deprovisioning of the many users? What tools do you really use to help user activity and detect security threats? So these are also very, that means what we discussed in last half an hour is the new services which are there. They are basically important from the many point of view. I will conclude this session here, then I'll go to other presentation. Give me some few minutes time. So as a part of the our FDP, we talked about the little bit about the cloud security also. Means what are the issues to be addressed in the cloud security and what we should know. And I give you some high level overview, but not complete details actually. So where the security is, one is private cloud. You have a lot of rules and regulations which you need to follow. Public cloud, you have some flexibility. That's what the hybrid cloud means. We talk about the public cloud only. Okay. And we also talk about the multi-cloud. That is also another way of security. So public means basically you talk about economy of scale and cost effective. Whereas private means you talked about more control and often sensitive operations. This is very, very important. That means you have the you need to manage the security across two environments. That means here you have the public cloud consists of maybe 10, 15 sites. Private cloud consists of 10, 15 sites, and your application is running on the both the things. What are the vulnerabilities, and how do you have the managing access identity? How do you have the data protection? How do you have the compliance requirements? I'm skipping some slides actually. Most importantly, security is very important because data and services spread across various environments, and data often moves between private and public clouds. And also you require encryption and proper access control. That's why new services have been really there. And also data flows, what data flows, and how do you have the security data flows, and what are the ports which appear that makes the threats for the security. All these things are very difficult to really find out when you talk about hybrid clouds. In a private clouds, everything has been tightly integrated. In the public cloud, it is not integrated. But when you have both the things, it's much more problems actually. So what are the issues? One is increased complexity in hybrid cloud environments. Second one is misconfiguration risks. And third, data leakage protection challenges. Fourth one is network security. Skill group, lack of cloud expertise, compliance and governance issues in hybrid clouds. All the six are basically challenges where we need to invest time to understand the security. Let's see each one. Hybrid, increased complexity. That means you as a cloud service provider, you should know how the data has been accessed, how it is stored across environments. This is the real-time visibility is required. That means the cloud security teams should write more scripts to understand access mechanism and storage mechanism. So that means we need to write more scripts to check. Once you write the scripts, we should have the web portal to display, then only we can see. Security policies actually. Security policies may vary from the cloud provider to cloud provider. Because of the, you may require GPUs, you may require CPUs, you may require more memory, you may require more storage, you may require this many hours of running job on the cloud. All these policies have to be in place actually. And also we discuss about the identity. That's where the authentication and authorization and security compliance, threat detection, all these environments we need. So how do we really handle these things actually? That means you need more tools, you need different security protocols, and you require compliance and various cloud infrastructure. So these three we need to address it when you talk about the complexity, because the increased complexity means the the user requires more resources in the private or more resources in the public, or a combination of different heterogeneity in both the things. Then what is the compliance across this infrastructure and how do you handle? That is also another important thing. Now misconfiguration means you may configure a cluster, you may have the environment, and you would like to see the which are the ports open, which are the ports closed, and is encryption has been done for the all APIs, is database permission has been set or not. All these things again you require management tools. Here the management tools means we write many scripts. That script will run continuously to check whether the permissions and ports open or not actually. If we don't do a lot of threats will be there actually. Okay, so this is also called if a cloud user, security user is not well trained, he or she may open up the ports open. When the ports are open, a lot of data will come, the data will be leaked. So that we need to have the every security team member should expose to the tools which really sets the security of the entire infrastructure. So the cause of cloud breach is also another one which we need to understand. The Amazon has got different kind of data, that is S3 buckets. S3 buckets are basically used in Amazon W services. Now, what is important is they provide, but user has to create buckets, user has to organize, manage data with controls on access. With controls means user should know how to implement control on access, what is the version which is there, what is the life cycle, and how much data you are putting in storing in S3 bucket. All these things we need to do actually. Sometimes the service provider provide many things, but it's responsibility of the user as well as the service provider to check actually vulnerabilities in this actually. That means basically the user is more worried about the access control. Access control is there or not, which we need to understand. Okay. This especially happens in the case of medical health records, medical images, and videos, and documents, much more. These are all can be shared in S3 bucket, which is again container they use actually. So S3 bucket container, which was not used in the earlier version of the cloud, now they have changed completely. So this is also another issue which we need to understand. So data leakage and protection changes. I told you already that there is a insecure APIs as well as the fully secured endpoint, as well as the how access to the sensitive data has been controlled or not. All these things also very, very important when you do the data leakage and protection challenges. So in all these things, what we need is, as a developer, we need to write many test scripts and scripts, and we need to use many tools to check whether everything is okay or not before I use my cloud. So that means what? Encryption, secure API gateways, and data loss prevention tools. That is also, are you authorized to transfer some sensitive data? Are you unauthorized? How the gateways and authenticate the protect your APIs. So encrypt data. So all these things which are not there in the public clouds completely. Private clouds, they implement all the things actually. Because when you move the data from multiple clouds, multiple cloud environment, these difficulties also we need to understand. Securing data in transit, that is also another one which we need to know about how the network is set up, how the entire infrastructure security protocols has been laid on, how the data flows across public and private clouds, how many networks are there, each network, what is the L1 switches, L2 switches, and how many edges, how many forks we configure, all the things we need to understand. And we also have to know the firewalls. In other words, we need to do virtual private path, virtual private networks. Okay, 40 clients, something we can use it so that you have the virtual pathway to connect, virtual secure pathway to connect from one system to other system. And then how the traffic is visible, how the traffic is related to the blind spots, all these things come under the security only, which we need to understand. So use virtual private network, secure tunnel for a data travel between clouds, encrypt data in transit, zero trust network. That means no user or device is trusted by default. When you create all these things, your network is more secure. As a student or as a cloud developer, I need to write many scripts and cross-check whether everything is successfully executed or not, whether security aspects have been taken care of or not. So that is also we need to understand. So when we these things we'll be discussing in the coming lectures, more details also actually. So what is observations? You have to bridge the cloud, bridging the cloud expertise gap. One is in cloud, everything is dynamic. You are managing security across public and private clouds. That means some in your traditional cloud in your campus, it's more on static environment, that is with fixed controls. When you have expertise on a cloud setup in your campus, when you move your expertise onto the actual private clouds, everything is dynamic. That means we need to understand the skill set for the configurations or the identify what kind of threats will come actually. All these things are require nothing but specialized training in cloud security. In fact, many institutes, cloud security is the one course which they offer, where you are talk about hybrid cloud security, private cloud security, and public rights security, and they discuss also. So that means you look for the more courses in the hybrid cloud security. That is also another area. Now, compliance. Compliance means actually it varies from cloud provider to cloud provider actually. Some cloud providers more about the securing the infrastructure. Some are responsible for securing the data, applications, and configurations within the cloud. Every cloud provider handles their own compliance. In the case of only databases processing on a cloud, there are different kind of cloud compliance. In case of providing high performance computing, high throughput computing kind of system, different kind of compliance. So all the compliance we need to check, and then we need to write test scripts to see whether the compliance are we following or not actually. So mostly, besides getting the results, we need to more worry about the securing the data, as well as securing the application, as well as which configuration our cloud is run, what is the pay and use policies. All these things we need to understand in the hybrid cloud environment. So stay with compliance. That means always ensure that all your tools can manage security policies across multiple environment. And then comprehensive policies has to work for the both public and private accounts. And you need to audit the quarterly security audits. In fact, in many industries, the audits happen every month to see whether the systems which are working is compromised or not. What are the vulnerabilities are there? So the cloud security boils down to development of tools and then scripts that we need to focus more as a part of many of these BTech, MTech theses, so that we'll understand completely. Same thing, I just skip some slides. Now we'll see I also talk about the high level overview about multiple cloud environment, how you preserve identity. That is also another issue. Today, almost all you will be working on multiple cloud environments. Cloud environment. Okay. Where we have to go? Okay. So we need to understand privacy preserving identity. Just one interruption.
So meanwhile, that professor is busy in some other important work, I would like to emphasize that whatever that he is stated pertaining to that, the research work we had undergone. And in this, the thing is that we during in my talk and the presentation and the practical environment we will give you as a part of that hands-on experience pertaining to that all those type of that hybrid and asynchronous distributed computing environment where the vulnerabilities are also the key issues pertaining to that. We have done a very tremendous and efficient work but which is giving that 100% reliability without any having that intruding attack, and that is that what we have achieved. That shall also be demonstrated in my presentation pertaining to that multiple type of that platforms that we have used and emphasize on how to mitigate such type of the attack. As the professor has said that in such type of the scenarios, the challenges are there because the platform are varying, the software are varying, the operating systems upon which that platform is running is varying, the speed and that the mode of that communication is also varying. Pertaining to that, each and every level of abstraction, there are the multiple number of the platform, multiple level of the abstractions where that protocol are required that need to be changed. And in that, those type of the triggering things which need to be monitored and controlled. Pertaining to that, the secure based environment, which is a more likely to be emphasized while making such type of the environment, we require to have the better type of that simulating environment to emulate using the different type of the hardware and software tool. Pertaining to that, the exercise that shall be demonstrated to you, and using that you would be able to understand that how such type of the system can work. Now, having in such type of the scenario, the thing is that we have gone through using the visual same. We have gone through the Libelium. We have gone through this connectivity of this edge computing with that multiple type of that hardware scenario where that in between intermediate node service and the control based service that is already been there in that fixed infrastructure based type of the service which we do have in our possessions. Using that, the edge based network has been created and all sort of that vulnerability pertaining to that attack, man in middle attack that has been explored. So in that, the challenges are there where we require to have the better mechanism for making the evaluations and trying to explore that vulnerabilities and then mitigate them. So pertaining to that, the challenges are there to make the similar type of that patterns which is to be used. So in that case, we use the different sort of the library like the smart, but to make those type of that attacking environment in the network, cloud-based network, and at the different level of the abstractions in between within that cloud where that can be easily targeted. So pertaining to that, having those type of the knowledge and having those type of the protection environment which need to be added over there, we would claim that our system would be more sophisticated without any vulnerability, or that would be the minimal vulnerability. Pertaining to that, the machine learning approaches are also been added and emphasize on that, having known those type of that attack in advance, and that if that has been created over there, in that case, the system would be able to learn that and would mitigate any sort of that attack by isolating those nodes which are creating the problem. So the problem pertaining to that, the speed, the throughput, and the latency are there. And another important aspect is the power optimization. So having a different type of those scenarios pertaining to this cloud-based environment, as you know that the challenges are there to minimize the power while making that maximum computation. So in that case, the resources which are being used, the amount of the power which is being used by the resources, the equivalent amount of that is required to cool them down. So pertaining to that, it is emphasized that the system should be fast enough to compute in the minimal time span and give that result without waiting for the longer period of the time. So in that case, the challenges are there that latency, jitter, and the throughput that need to be optimized. So the latency need to be minimal, the power dissipation should be minimal, throughput should be maximal with that highest bandwidth available. So in that case, the resource requirement pertaining to do the high performance computing tasks or the deep learning part, where that large data resources and the database and the infrastructure is required. Our system, which upon which that operation need to be performed, that has to be robust enough to handle all these type of the challenges. So pertaining to that, the Professor Rao has highlighted all those different type of the platforms and their services and their interface and connectivity and the type of the services which are being currently provided by the industry. So in that case, pertaining to that, the practical hands-on type of the experiment that shall be demonstrated to you, similar type of the exercises on those type of that platform, if that can be configured in the remote distance, I will ask my teams to provide such type of the environment so that you would also be able to run that with their own hand to understand that how does this cloud-based environment can be created and what type of data services that can be configured and how the script that can be executed to perform the different sort of the task in order to make that entire computing environment over the cloud-based network. So over to you, sir.
Thank you very much. Sorry for the interruption.
It's
I
okay,
would
sir.
like, I'm audible now, no? Okay, no?
Yes, sir, you are audible and visible.
The another area where we should get in high level view about the security with respect to the multiple cloud environment. In fact, today we are giving a high level overview. Maybe at the time progresses in our FDP, many of them talk more details also. So what I'm talking about is that identify multiple cloud environment privacy preserving. Let us know about the background. On-demand access to computing resources and increasing reliance on the cloud services has put more seriousness on security, particularly identity and access management, IAM actually. This is also controlled by the cloud service provider, and we should understand this one also. Normally, when you have the clouds private, public, and hybrid and federated clouds, each has its own unique challenges. Then how do we address? In the past, we have more federated clouds. Later, hybrid clouds started. Now people are more worried about the privacy preserving in this kind of clouds actually. And we also discuss about we did not discuss much, but we know very well about these services. But these services were not discussed about the strong authentication authorization. Normally to address the risks, various risks. Then we also discussed a little bit about the identity database as a service, function as a service, identity as a service, and anything as a service. That is also has come actually. Okay, that means what? All the kind of services which require amount of heterogeneous data.
Professor Link is disconnected anyway, but we shall continue. If it has been there, in that case, I shall try to continue that part. So in that, the emphasis is that maximizing of that efficiency or in the cloud networking environment, nowadays the flexibilities are there, which the Professor V.C. Rao is explaining. So over to you, sir.
Thank you. So now, as a cloud service provider, as a cloud user, we need to understand how the cloud system address performance and scalability issues for my application. Before that, we need to understand what kind of risk management issues, security challenges we need to know actually. So because most of the clouds which are dependent upon the service-oriented architecture, which we used to call as a grid computing around 15 years ago, all these things basically focusing on security issues and the complexity of cloud system and how do you address these things actually. So one of the things which we need to more worry is how the IAM systems offer authentication, authorization, access management services, digital identity management, how the risk can be mitigated, how much data is vulnerable, how cloud adoption is done, taking care of all security is our major concerns actually. So IAM systems address many of the new security challenges. Now almost all the cloud environments, they provide a digital identity. That means service provider verifies identity for personalized account services accountability and ensuring secure authentication, authorization, and access control. All these things are observations which are there. Now, what people have made some effort is a reference architecture where multi-cloud setting. In multi-cloud setting, you have many layers, user application layer, solid framework layer, that is where the storage of user data, and cloud service layer. Now the concept of the blockchain also used for the distributed databases in the multi-cloud environment. And this is another research area which many of them are now contributing. A multi-cloud environment, privacy preserving, and then distributed database application, and how do we really handle actually. So this picture gives only 3 layers identified, remaining are not identified completely. But for ease of case, you have a new one called solid framework layer, where they talk about the storage of user data in certain fashion. And then they use the blockchain and peer-to-peer network. Peer-to-peer network is one of the earlier generation of distributed computing paradigm, where the peer-to-peer networks and blockchain is used for the distributed data. And then service provider, which we talked about, the many of the new services also. So what are the major core topics which we need to understand? One is authentication and authorization, and then identity verification and risk management, attribute management, security and privacy, audit compliance, and user lifecycle management, interoperability, and federation. These are the 7 core topics which are identified as the digital identities across various cloud platforms. Each cloud platform may have different practices to implement these things, but all things will be checked that will come under the security and compliance, or basically audit and compliance actually. So now if you really see every site, you can write the scripts. The scripts will tell you about authentication, access control, privacy preserving, encryption, identity management, authorization, an identity provider, trust management, interoperability issues. Interoperability is basically depending upon the what application depends, what cloud services provides. Both things have the interoperability is there. The interoperability already exists in the traditional systems, whereas in the cloud systems, interoperability is still active research actually. So what you really see is that the digital identity management or the multiple clouds in security means all things we need to understand. Maybe in the coming 5-6 days, people talk about many of these things in more details, which I am not covering. I just giving overview actually. Let me talk about the what we need to know about the cloud security analysis. What you call cloud threat landscape. How the cloud threats are happening. Cloud specific attack vectors. How you really address this thing. How the threats in the cloud environment actually. The new concept has come called Cloud Security Posture Management, CSPM, which basically assesses and analyzes the misconfiguration and whether continuously compliance is being monitored or not. What are the strategies if compliance is not monitored? So this CSPM is also another one which we'll be discussing in the subsequent lectures more. Identity and access management, IAM analysis, which I already gave some basic things. These also we need to know. And data security in the cloud. One needs data encryption at rest, in transit and in use. That is encryption strategies we should know. And then we have the cloud network security analysis, and we have monitoring and logging analysis. In all these things, some things we can write the tools, but something we should know what is basically meaning of each one actually. How they really implemented, what are the things we should get idea actually. Now we talked about little bit about the VMs, containers, Dockers, and how the container security analysis. We also talked about the function as a service, serverless security, and what are the vulnerability in the cloud workloads, and third party and supply chain risk. These also we need to understand. Let us go through these things. I just skip. So I'll talk about the certain things and I will cover remaining things because we have another 5 to 10 minutes time is there. Virtualization container security analysis. What we need to know about the virtualization container security? Means how the environment is there, what are the breaches are there, how the workloads have been defined, and the how to assess the security risk. These things are very, very important. How do you write the scripts and provide? These are the issues which we need to understand. Container security analysis, how many VMs are there, how the hypervisor manages them, how many VMs are having workload, how the VMs working on the underlying host system. That's about the virtualization. Now, container security is how many container deployment, and then configuration, runtime security, how the container orchestrates the many platforms, what are the security policies, all these things also very, very important when you talk about the dimensions in the cloud security. So I would like to conclude in another 2-3 slides, then we will discuss maybe in my next presentation about the application and API analysis. This is very, very important. API vulnerability analysis, secure DevOps. Now the threat intelligence. Let us talk about only secure DevOps and then close it. Secure DevOps means what actually? It's a modern approach where security practices can be directly into your software lifecycle. When the security practices, that is maybe programming APIs or the scriptings which are in the software. Now that means earlier the security is separate or later stage activity. Similarly, earlier testing is separate and later stage activity. But now DevSecOps embeds into security as a shared responsibility among developers, operations, and security teams also. That means you have the security team, you have the in-premise cloud operation team, and you have the developer team. All things should know about the what are the security practices which we need to put in our program, and what are the data you write, data you read, and device availability. All things we need to put under the continuous security checks actually. That means what? This all looks like a real-time monitoring from design to deployment and beyond. So design to deployment monitoring is a one concept where you speed up the overall development of application and checking the cloud available resources. Everything is very, very important. This secure develop apps is one area where many of them written the very good number of MTech and PhD thesis in this area, where they use a lot of encryption algorithms and everything. So after completion of security DevOps, I would like to summarize and close my session today. So security as a code and automation, that is also continuous investigation, continuous deployment for pipelines, and that is under the how we can integrate all these things in a one framework and then try to see that your software is completely automated actually. So security policies and testing scripts, logical testing, performance testing, everything have been integrated in your software actually. Security vulnerability assessments, secure coding, threat modeling are now coming into the first phases when you develop the software, so that the life cycle of the complete development can be reduced actually. Now other one is that as and when the modules have been written, you automatically invoke the checking of the threat intelligence for the cloud applications, infrastructure services. So this is development point of view, infrastructure point of view, in application point of view. That application means no data should be leaked. All these things we need to check actually. Whether device is available or not, whether you have read permission, whether write permission, all things we need to check. So these all will help you to overall speed up the deployment of the application also. Now there are other tools also there: cloud security posture management, cloud workload protection management platform. These are also very much used. That I will quickly give you one slide and close my thing actually. That means your cloud secure posture management means it continuously checks a script with running, a daemon running for misconfiguration and risk and compliance violation, everything actually. So that means it will check whether the all services are basically well compliant or not. If there is not compliant, if there is a threat detection, it will immediately it will trigger and then the problem will be fixed actually. So this is also very useful in the hybrid clouds and in a multi-cloud environment. Workload protection is another one where the how the applications are running. Is application running on distributed computing platform? Application are running on large shared memory platform, or is application is high performance? Application is more IoT devices, or application is reading database and writing database? Is application requires many containers, or it only uses VMs, or it uses serverless functions? Then how do you really manage all these things through security perspective, and how do you really provide security programming APIs, taking care of all these kind of workloads actually. So this is also another one which is very useful, cloud workload protection platforms actually. So now there are many use cases are there in both the things. We also discussed about the S3 bucket of Amazon Web Services and then other things. Now what I do now, I will just stop here, then I will take a couple of questions. So let me just quickly tell you what we have done today. An overview as being a first lecture, we gave a little bit about overview about the cloud services. And last we talked about what are the challenges in the cloud security. Before that we discussed about the cloud services. Totally 6 services, new services which we discussed: container, serverless, and then identity, and databases were very important. Then before that we also discussed about the overall cloud computing background. So this is a very good introduction to overall thing, and each area is very vast, which I discussed in my slides also. So with this, I would like to take a couple of questions, and we'll close our today's session actually. So these are the overall topics which we plan to address. Many of the faculty members have a very good expertise in many areas. I have selected only very few. Maybe 11th again, I'll be talking more about the cloud systems and everything, and we also demonstrate some codes about what we are doing on the big data, and then how to.
Right, sir, right. So because in this particular, the emphasis of this particular cloud analysis and security program was that having the practical simulation and that hands-on experience on the emulated environment using the small cloud-based system, we have gone through of testing all these challenges that you have discussed. Specifically in this, the load balancing pertaining to that, the odd even or that asymmetric type of that environment which are being created, vulnerability issues pertaining to that, the intruder attack or that security concerns at the different level of the abstractions. A very good research that has already been done by our research scholar pertaining to that, the talks, our talks that shall be delivered. So I hope that having a base of that, what type of that cloud system computing is, and the challenges which the Professor Rao has focused, I hope that those type of that challenges will be discussed in the greater detail with those type of multiple ways of eliminating those challenges and maximizing the performance of the cloud-based network with that maximum robustness. Pertaining to that, specifically that the challenges of transmission of the data in the distributed cloud environment where the source and destinations are required to exchange their information. So in that case, the man-in-the-middle attack or any other sort of the attack or during this exchange of the data, that can also be identified and that has to be mitigated pertaining to that new algorithms that has been created, and we have given that it been like the situations where that vulnerability issues are there, and if our algorithms would have been used, that vulnerability like that, and the compromise of the resource would not have been happened, like that the Shamoon attack which has been done earlier, which is another ransomware type of that attack which was done. So I thank you, Professor Rao, for giving this valuable information in his keynote talk, and explore all those type of that issues pertaining to that configurations requirement and the need and use of the different type of the platform for the different situation. So having those type of the basic awareness about that, the further extension of that part where those explicitly those type of the situations where the challenges are there and we explore them, and that shall be discussed in the upcoming sessions. So once again, I thank you, Professor Rao, for elaborating all those important issues pertaining to the cloud analysis and security. Thank you very much.
Thank you very much. I definitely share my presentation today or tomorrow. And
So what, Agam, will you speak or should I? Okay. So all the participants, please note that the slide pertaining to the topics which has been covered, that shall be given to you. From that, the topics which has been covered, the questionnaires will be asked. You will have to submit that as per the instruction which will be provided to you. Thank you. Thank you,
somebody
sir.
wants my email.
Any question? So put your question in the chat box.
Take it.
Okay, so sir,
Yeah, couple of
asking your contact number and details, contact details. So
Can
kindly
we,
put that on the
let
chat
me write
box.
my contact number here itself.
Yeah.
Yes, people are welcome to contact this number on my WhatsApp also. Thank you very much, and I appreciate HOD Dr. Mustaq for taking his valuable time and spend almost all 2 to 2.5 hours, which is very precious because he has more administrative responsibilities and he has more teaching workload as well as
Yeah.
high level
After that, I have to go to take the master's class. Yeah.
I sincerely thank you for spending your valuable time, sir. With this, I give to organizers to close this 2-hour session. Thank you.
Okay. Thank you very much, sir. Thank you. So the next session will start at what time? So dear participant, the next session would start at the 4 o'clock sharp. Please do join. So those who have not joined in this session, the first sessions, I hope that the next session they should surely join.